Now we're going to talk a little bit more about influence diagrams. In this discussion, we'll talk a bit more about classifying the different nodes or variable objects in Analytica. We've talked about this briefly, the various objects that we would generally work with in terms of creating a decision model. First, we use the rectangular objects to represent decisions. A decision might be how much money to budget. It might be what price to set a product at. It could also be something like which sort of policy to enact. So decisions can take many forms. Then there's the objectives, where we use this hexagon. Objectives could be financial, environmental, health related. They could be some weighted combination of all of those things. A lot of times we'll have multi-attribute objective functions, and the attributes could have totally different units. Things like financial, it could be in terms of dollars. How much is it going to cost? It could be in terms of safety. You want to combine that into a single objective function. Well, you have to be able to normalize them onto the same units of measurement. And you can do that through scores. A lot of people will use it by just converting everything in dollars. There's different methods of weighting your various objectives so that you could combine them into a single score for different decisions that you have available to you. The next object is the oval uncertainty. Generally, this oval is really for a probability distribution. I don't want to limit uncertainties to just probability distributions. An uncertainty might just be a range. Then we have this final shape. We use it for hard-coded data, something that isn't being calculated. It could be something very simple, like how many days are there per year? Or it could be a big database worth of data that you have on customer demographics or product costs. A really important concept is distinguishing decisions and chance variables. A chance variable is something you do not have control over. It's random, like the weather. We don't have control over the weather. In any given hour of the day, there's some probability that it might rain. We would model the likelihood of rain or the event of rain as a chance variable. A decision, on the other hand, is something we do have control over. If we're talking about weather, our decision would be, do we carry an umbrella today? Do I wear a rain jacket today? That decision might be a function of the probability of how much rain there is going to be. I'll spend a little bit on this. So an index is nothing more than a list. We could create a list for countries, or a list for regions, or a list for years. It's a way to categorize our data. There's also this shape that we use for user-defined functions. If you need something very custom, and it's something that, some sort of calculation or operation you're going to be repeating over and over again, you can create your own function. When we get to optimization models using linear programming or network programming or integer programming, where we're doing true optimization that's using a solver engine, we have the ability to add these new objects called constraints. And that's where you could say, okay, I want to maximize my profits under the condition that I can only invest $1 million up front. That condition is a constraint. We can model that constraint using this object. There's text boxes. And then for some more advanced features, we have some buttons that execute some sort of command or some sort of operation.